My name is Alex Singh, and I'm going to be presenting Exam 1 Solutions Part 1B. So this is a ranking problem, and we are asked to rank the molalities of 3 different solutions. The first solution has 0.0382 grams of sodium chloride in 250 milliliters of water. The second solution is a 0.0344 molar solution of sodium chloride in 300 milliliters of water. The last solution has 0.542 grams of sodium chloride and 750 milliliters of ethanol. As a review, molality is equal to the moles of solute over the mass of the solvent in kilograms. So for the first problem, we're given the mass of the solute, and we can convert to moles of solute by dividing by the molar mass. So we have 0.0382 grams of NaCl times 1 mole over 58.443 grams. And that gets us 6.54 times 10 to the negative 4 moles of NaCl. And that is the numerator of our molality equation. So now we have to solve for the denominator, which is the mass of the solvent. So we know the volume of the solvent, which is water, is 250 milliliters. And we also know that the density of water is 1 gram per 1 milliliter. This equation so far gets us the mass of the water in grams, but we know that the molality equation demands kilograms, so we have to use a conversion factor to get from kilograms to grams. Solving this out, we get that there are 0.250 kilograms of solvent. We can plug these values back into our molality equation. 6.54 times 10 to the negative 4 moles divided by 0.250 kilograms to get 0.00261 molality. Now, the second question is a little bit different because we're given molarity instead of the mass of solute. So remember that molarity is equal to the moles of the solute over the volume of the solution in liters. So for this problem, since the NaCl has such a small mass compared to the mass of the water, we can assume that the volume of the solution is equal to the volume of just the water. That being said, we can multiply the volume of the water by the molarity, 0.0344 moles of NaCl per liter to get the moles of NaCl, which is our solute. So we'll get a 0.01032 moles of NaCl. That gives us the numerator of the molality equation. And now we have to solve for the denominator of the molality equation, which is the mass of the solvent in kilograms. So to do this, we do a similar procedure to what we did in the first problem. So we know we have 300 milliliters of water. And again, we know that the density of water is 1 grams per milliliter. And we have to convert to kilograms because the molality equation demands the solvent to be in kilograms. That gives us 0.300 kilograms. So now we have both our numerator and denominator. We can plug it into the molality equation. Moles divided by 0.300 kilograms. And that will get us 0.0344 molality. For the last part, we have 0.542 grams of NaCl in 750 milliliters of ethanol. In this question, we have to be careful to pay attention to the density of ethanol because it is not the same as the density of water. So to find the moles of our solute, we have to multiply the grams of our solute, which is 0.542, by 1 over the molar mass. And that gets us 0.00927 moles of NaCl, which is our numerator. To solve for the mass of the solvent, we have to multiply the 750 milliliters of ethanol by the density given in the problem, which is 0.789 grams per milliliter. Now, again, we have to convert from grams to kilograms. And that will get us 0.59175 kilograms. So, plugging this back into our molality equation, we have 0.00927 moles divided by 0.59175 kilograms, which gets us 0.0157 molality. We can then see that number 2, 0.0344 molality is greater than number 3, 0.0157 molality, which is greater than number 1, 0.00261 molality. To recap, the purpose of this problem was to compare the molality of 3 different solutions. In the first and third solutions, we were given the mass of the solute, and in the second solution, we were given the molarity of the solute. We also needed to utilize the density of the solvent in solving for molality.